Check one, check two. Hello, hello. I think we are live. Happy December from wherever you are in the world. So this is your week 10 recap for the IBM Data Science October 2025 cohort. I'm still Alexander, and hopefully you'll all have had a great semester here with us. I know I've already kind of learned a lot from working through all of this content and seeing all of your engagement in the forums. We'll keep this one short and sweet. Hopefully, we will kind of start probably with the content recap and then jump into the logistics. We had our last live session of the course earlier this week for week 10. For the second half of the Capstone project, which is, of course, what week 10 is having you work on, we're taking all the data that we extracted, transformed, and loaded last week, as well as done our basic EDA, and we're actually making deliverable data products. So what I mean by that is that we are creating interactive dashboards, we are creating machine learning models, and we are creating just actionable insights off of this information. So we're going to be creating Folium maps in Jupyter Notebooks. We're going to be creating an interactive Plotly dash dashboard with Plotly and HTML. And then, of course, training our classification model to predict the probability of a SpaceX launch landing successfully. Again, if you missed the live session, you can catch the recording at that link right there. And if you're tracking in my GitHub, all of my GitHub content for week 10 is available as well. We'll work through at a high level, kind of what we did. I don't know if I have any specific code. There weren't that many gotchas. The Folia maps for 10.1.3, this was your first deliverable for week 10. You needed to work your way through a Jupyter notebook. And in that Jupyter notebook, you're going to be creating a Folium map that's interactive. There's only a couple of gotchas here. Note that you ended up having to make three different maps. They each kind of built on each other and increased in difficulty. The first was just a map of all of the markers for the launch sites. The second was a marker cluster where you had one marker per launch on top of those launch sites. And then the next was adding in some interactivity using the mouse position plugin, as well as calculating distance and adding in annotations for the nearest road, coastline, railroad, and city. So this was kind of fun because we introduced haversine distance, which not a lot of people have heard of, but it's basically how do you calculate the distance on a sphere using great circle distance. So definitely give that a check if you've never kind of thought about that before. I think the only gotchas here, let's see. Creating the icon is kind of funky. There's a couple different ways you can do it. So note that if you just use kind of the default or some of the previous examples, this ends up just being kind of like an HTML specified icon using your text. So there's no actual like icon here. It's just the text on like a dot. So that's kind of what you see here. But if you wanted to add an icon, it's definitely possible. I recommend looking at where is it? I thought I did it here. Oh, it's in the live session one. In my session 10.1, this is where I worked through all of it kind of on my own time, with my own kind of syntax and flair, I guess. You can actually create an icon. Where are you? There we go. Just using a Folium icon, right? So that's kind of what this guy is right here, this Folium dot icon that'll actually create like a specified like index marker that looks like this. I wonder if I can actually load mine. I wonder if I thought I could host it there. Let me actually open it up real quick just so you can see what I'm talking about. Because they're like, what do you mean that doesn't actually make a marker? Um, Boom. So here is my map. We'll talk about how to save this off in a second. But if I zoom in, there we go. Look at that. Beautiful. Look at the little red and green little marker icons. I think I did not add in a pop-up. My bad. Sorry. Or the text here, but you can kind of see what I mean. This is like an actual real life, like red green kind of marker, versus some of the defaults here, which are more like just text icons. So again, million different ways you can design this. You can also build this icon out if you do use a div icon like they want you to. Um, Let me pull up my live session code again. Anyway, long story short, there's a lot of ways you can build and design this icon. And I think to me, this goes back to the larger idea that front end and how your users are interacting with the visualization is part of the whole data design, right? So this is where you can be creative, think about the user experience and how exactly you want to communicate what your data looks like. I'll also say that you have a decent amount of freedom with the second half of the Capstone project here. I think with extracting the data and transforming it, there's only really one way you can do that properly. But creating these visuals, creating the dashboard, and even to an extent creating the machine learning model, you have your own fair share of creativity that you can add on top of it. So that's the first gotcha. Make sure that you create the icons however you want to. We're not going to get too picky with it. But again, creating the icons can be kind of funky. The other part of this that was a gotcha for 10.1 and the Folium maps was the need for the notebook to be authenticated. It doesn't really work too well within the default environment. So what I actually recommend doing, if you actually check my live session code, I programmed this live during the live session within our working environment. And how I actually got it to work was by saving the map as in HTML, like a web, an interactive web object as opposed to just trying to display it within the notebook itself. So definitely recommend saving off the HTML map as you go. You can save it as often as you want and then open it up after each checkpoint, and you should be able to see the map kind of grow progressively as I mentioned. That's also how I opened this guy, by the way. This is from my own, just playing around with the activity, opened up the HTML, saved it off as HTML, and opened it up as a web page here for you. So that's the first part of week 10, creating this interactive Folium dashboard based off of Jupyter Notebooks and HTML. The second part is 10.1.4. This is going to be your Plotly dashboard. And just like 10.1, it's progressive. You're going to build onto it for the individual tasks. So you're going to be creating a drop down so you can select all the different sites. You're going to be creating a pie chart off of that. And then you're going to be creating a either scatter or bar chart. I think the instructions ask you to make a scatter chart. In my live session, we discussed why a bar chart would actually appear better here in terms of the data story. So whichever one you want to do, and actually provide examples of all of those. But again, it's a progressive dashboard. And again, you have some creativity here. You can change the colors, change the text, again, change the visualization type. Honestly, whatever you want to do. So again, we built this during the live session, and you'll see kind of my examples here. The one with the scatter plot that I want you to do, the one with the bar chart that Karen actually helped lead and design, and then the data set that you need for it that you download. So again, this wants you to create it inside of the VS Code like user environment within our an ecosystem. But make sure you right click and download those files just so you have them for your local backup as well. I don't think I have a good screenshot of what this actually looks like. I'll say I don't have it up so I could run it, but just use your imagination. It looks pretty good. And then finally, the machine learning model. It wants you to try out and build a logistic regression, SVC, decision tree, and KNN, and then use things like the classification report, confusion matrix, and ROC-OC to figure out which one is best. During the live session, I went deep in emphasizing ROC-OC or the ROC score here. Mostly because we only have a small training set, right? We only have 90 rows and our test set's only 18. So even after we do our cross validation and our hyperparameter tuning, our type 1 and type 2 errors are essentially the same for most of these. However, the ROC score takes into account the probabilities of the model, which gives us a better kind of one single number to kind of understand the performance of the model. So I'll actually demonstrate that here. If I go into again, this is the one I did during the live session. You can also see the one that I fiddled around with on my own time before the live session. But in the live session code, Yeah, same deal. Like I said, we're gonna bring in a whole bunch of algorithms, make sure we bring in metrics like the classification report, confusion matrix, and the rock score. And then we do all the work, and here we go. So this is for the logistic regression. You're going to see that it has three false positives and three false negatives. Wait, no, just three false positives here. We predicted that it landed when it did not actually land. So we got three false positives, and if you actually run through all of these, that's the same for all the algorithms. Three false positives. This one's bad. Three false positives, three false positives, three false positives, etc. So how do we actually determine which is the best model, given that like five out of the six that we tried all had the same amount of false positives? So if we look at the rock score, we'll see that the rock score, which takes into account the probabilities of the test set, we end up with a rock score of 0.91. Again, higher to 1 is better. Again, this kind of measures the area under the rock curve. So that's actually really good for our logistic regression. And we can actually compare these one to one. So this is the logistic regression. Then we run into the support vector machine. Yep. And for the support vector machine, we also had three false positives, but it had a rock score of 875. So by just looking at that, the logistic regression performed better, even though they had the same number of false positives. Our rock score metric is acting as a tiebreaker here, and the logistic regression performs best. And if we keep going down, I think we'll see that rock score is pretty hard to beat. So yeah, we can see this one. This is the single decision tree ends up performing the worst with six false positives, and we also has the worst rock score of the lot. KNN also has a pretty bad rock score compared to the linear models. Remember, support vector machine is a type of linear model, just a more exotic linear algorithm. And then I also ran this on random forest and XGBoost just for grins. And the random forest also had a worse rock score than the linear models. And XGBoost barely outperformed the support vector machine, but still had a worse rock score than the logistic regression. So for your model selection here, I would recommend the logistic regression is fine. But the XGBoost maybe if you think there's nonlinear factors at play. But anyway, have some fun with it. Like I said, I think there's some ways you can actually go ahead and like rope in some of the pre-processing steps we did in week 9, and you can actually make a pipeline to do things like your one-hot encoding and your standard scalar and all that jazz that we talked about last week. And then we also discussed how to save the model, so you can use the pickle or joblib library to save the binary file off and then deploy the model in a Docker container to some serving endpoint somewhere and call it a day. But I think high level, definitely look at the rock score, understand why the rock score as a metric for classification can be used as a tiebreaker, especially with small sample sets and when accuracy and other kind of metrics like your precision and recall are tied across your models. Cool. So that's the long story short for week 10. Three deliverables. Each deliverable is fairly large in scope. And again, it took me about 2 hours to go through all of it on my own time. So again, I would allocate about 6 hours on your own. Hopefully, most of you have already done this going into the end of this weekend. And that leads me into the actual capstone submission. Take two. Just kidding. We're still doing this live. All right. So now that you've done all of week 9, you've written all the code. You've done a great job with your ETL and your EDA. You've done all of week 10. You've done a great job creating your data products and creating your dashboards and machine learning models. How are we going to actually bundle this up into your final capstone deliverable that you can submit for a grade or add to your final portfolio? So you need to have an assortment of items. Here is how I recommend you do this. So first, you should have a GitHub repository that's separate from your class. So you should create a new repository just for the capstone. And we walked through how to do this in week 9. So here is my example. In week 9, I created this repository called IBM Data Science October 2025 Capstone. And you can see I've uploaded some assortment of files from week 9 and week 10 to it. Once you have created this repository, your task is to upload all of the deliverables from week 9, all the notebooks, all your SQL queries, all your ETL and EDA. Upload all of the week 10 deliverables, including all three sections here, the Folium map, the dashboards, and the machine learning model training notebooks. Again, if you have trouble like understanding how to download some of these files, go back and check the past forum posts. Karen and I have gone into detail in, I think, the week 9 lounge. Oh God, should we try and see if it's there? I think it is. I believe. I'm pretty sure it's the week 9 lounge. If you go into the week 9 lounge and scroll down far enough, yeah, here we go. We're going to go into detail on how to download the notebooks, both the notebooks as well as the files. And we also have some best practices for GitHub and things like that. So definitely peruse the week 9 discussion lounge or rewatch the week 9 lecture. We kind of go ham on exactly how you should kind of set up this GitHub. TLDR, you can create the folder structure on your computer and then just drag and drop those into the GitHub UI. All right, so that's your first deliverable, all the code and notebooks that you've done. However, that's not actually what we're going to be grading, right? What we're actually going to be grading is a slide deck. That is the one thing you have to have. And it's recommended to submit this in the GitHub, but if you have to just submit it as a file, which we'll get to in a sec, you can just upload the slide deck. So if you go into week 10, if you go into 10.7 and 10.8, you'll find a link to the Capstone slide deck. Again, if you don't use Microsoft Office, that's fine. What I did, because I don't really use Microsoft Office either, I actually uploaded the PowerPoint slide deck into Google Drive and opened it in Google Slides, and I'm able to interact and edit it inside of Google Slides. This is totally fine. Once you have created the slide deck as however you want, you just need to download it as a PowerPoint and a PDF. But this is your main deliverable is this PowerPoint slide deck here. You need to go through, and again, you have some creative license. You don't have to be fully bound by this like slide deck. But basically, you need to go high level overview, what you did, what's the problem, how did you acquire data, how did you clean the data, how did you explore the data, and then the data products that you built at a high level. After you've gone over at a high level, there's going to be a deep dive in some of the individual sections. So we're going to do a deep dive into the EDA, basically insert screenshots from your notebooks of this from week 9 of your EDA visualizations. And then for week 10, same deals. We're going to do a deep dive into the data products for week 10, include some screenshots of your Folium maps, include some screenshots of your Plotly dashboard, and include some screenshots of your machine learning model outputs. Draft a couple of conclusions from the project as a whole, connect things back together, include any appendix items that you feel might be relevant, and that's it. So not too bad. So again, high level idea for the slides, you're going to start with an overview of the project. Then you're going to go into a deep dive in your ETL and EDA from week 9 and your data products in week 10. And again, feel free to have creative license with this. Once you've basically consolidated all of your notebook outputs into this PowerPoint, you're going to download it as both a PowerPoint and a PDF. And then you're going to upload both of the PowerPoint and PDF data files into your Capstone repository. Next, there's two optional items, but highly recommended items that you should also include. The first is a written report. Basically, take your slide deck, download it, upload it into your AI tool of choice, and tell it to generate an analytical write-up. Again, I linked this in week 9, but I think there's a good one in an analytics write-up. Let me find one in Geeks for Geeks. Let's see what comes back here. How to write a data analysis report. Blah, 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 blah. Basically, it gives a key overview. It's exactly the same thing. Start with big idea of what you try to do, deep dive in some of the individual sections using data visualization, tie it back into a data story, summarize your conclusions, and offer an actionable recommendation and output, right? and then link it back to your interactive dashboards for a more dynamic presentation. So same deal. Uh, Basically, take your slide deck and turn it into a 2 to 3 page write-up or executive summary to accompany your write-up. And then finally, GitHub is best when also using a README. This is a markdown file that gets displayed at the beginning of the repository. So you can see here for the October 2025 class, I have a README file that basically summarizes everything inside of the repository. Again, go to your AI tool of choice and it'll generate one pretty quick. But try and generate a README. Again, the big idea here is that this capstone project for this repository should be included in your resume, and that way potential employers or other types of maybe academics, they can click onto it and without having to dive into all the individual code and open up the PowerPoint or anything, they can get a quick overview as to the purpose of the repository and maybe a quick kind of summary and output of the findings that you discovered. So that is also optional, but again, highly recommended just for explaining the GitHub repository for your future portfolio use cases. All right, so if you actually read the documentation on how to upload your assignment, it does list two ways of submitting, file and text. My recommendation is to try and use a text submission and then just in your text submission, link to your GitHub repository. However, after talking to Michelle and a couple students kind of digging through this, it seemed like you could only submit via a file submission. This can still work. The file that you need to submit is going to be the slide deck. That is the one thing that has to be there is this PowerPoint. So submit the slide deck as a PowerPoint or PDF. PDF is always preferred. And inside of your slide deck, try and include a link to your GitHub so Karen and I can click into it and see all of your notebooks, files, and accompanying context, right? Remember, Karen and I are going to be the ones grading this. So the more and easier you make it for us, the more that's there and the easier you make it for us, the better. So I don't know if you can make it a text submission. I don't really have that student view, but if you can do a text submission, just submit your GitHub repo and you should be good as a URL. If you have to submit a file and you can only submit a file, only submit your slide deck as a PowerPoint or PDF, and just make sure inside of your slide deck you include a link to your full GitHub repository. All right, so due dates. Hopefully, you've already finished your week 10 content over this weekend. In the next couple of days, you should be working on finishing up your slide deck and organizing your GitHub. You need to submit this by the end of the 16th. If you submit on the 17th, that's probably okay, but just know that you should be aiming for the 16th at worst case. Karen and I will submit grades by the end of the 17th. We cannot submit like new grades after 11:59 p.m. Eastern time on December 17th. So if your uh, deck hasn't been submitted by then we're gonna be in a real pickle. You should have about 24 hours. If there's any questions or anything, we should be able to lock things down. And then everything will be finalized, submitted, and the course will close on December 19th. So that'll be Friday at 11:59 p.m. Eastern Time. Friday will also be the last day that we will be in the forums. If you have questions or want to submit any other content or just updates to the forum discussion posts. The discussion posts from week 1 to week 10 are technically optional, but again, I highly recommend just answering them just for exercise as they are applicable to the real world and how you will be asked to examine and interpret data science questions. So. Uh, cool. TLDR and dates. You submit on the campus your slide deck or GitHub repository, or preferably both, by the end of day on December 16th or 17th. We will have the grades submitted by the end of day on the 17th. And then the course will close on the 19th for the rest of the year and the holiday season. And then you graduate. So, how fun is that? All right. Let us know if you have any questions here. I think I've covered everything. This link on Geeks for Geeks was included in the week 9 summary. The slide deck should be linked in the course content. This is also included in the course content. My GitHub is obviously available in all the forum posts. And I think that's it. If I don't see you, have a great rest of your holiday season and a happy new year. Oh, there was a potential for an office hour session on Monday, December 15th. That is not going to happen. I have some conflicts and I didn't get enough kind of responses from people. So there's no more live sessions in this class. Last Monday for the week 10 live session was the last one. But if you need me, you know where to find me. And I think we're always happy to interact with you kind of as needed. So just reach out if you need us or have any questions, and Karen and I should be able to respond to you pretty quickly here. So, long story short, wrap your stuff up, get your last submissions in. We'll get the grades logged, and let's all get this done so we can enjoy the holiday break and the new year. Thanks for your engagement in the class. I really appreciate everyone kind of watching these videos and submitting this work and interacting with Karen and myself in the course and the course forums. I've had a blast over the last 10 weeks. Hopefully, you've learned a lot as well. Thanks for following along and happy holidays and have a great new year. I appreciate each and every one of you. I'm proud of all of you for making it this far. And I'm looking forward to seeing what you all do with this knowledge in the new year. Feel free to connect with me on LinkedIn and happy holidays. Thanks, everyone. You can find me on LinkedIn at Alexander-Booth-TX for Texas. Not that you need to really care, but there I am. All right. Thanks, everybody.